So importantly for these, it's using this process backwards, where it has to be 2 times whatever your A is times by whatever your B is. All right. So if we go down to a question, okay, where we've got this, x squared plus 12x plus 36, that has to be squared. There has to be a number that's squared to get that, and then this becomes your A and this becomes your B, right? So, and the process is the whole A squared plus 2 times A times B plus B squared. Yeah? Alright, so you're looking at this last number, that has to be squared, so then you get your B. Alright? And your first number or letter has to be A, and that's squared, and then you've got that. Alright, so when you go through and write that out in that process, you then find, so if we go through a little bit further down, to x squared plus 20x plus 100, you've got to find what it is squared to get 100, which we know is 10 squared. Okay, so you now know that this is B, and so that's why 10 went into there. Okay, A is the square of the first. We know that that's A, so you can transpose A into there. So when you put x squared plus 2 times x times 10 plus 10 squared, you're getting this. Okay, x plus 10 all squared. Because we know if we went and expanded that way, that's the process to go to fully expand it. So we're going back the other way. Alright, so how are they getting x plus 10 from this? It would appear they are eradicating all of that. Yeah? Let's have a look and transpose that. This becomes, of course, a squared take 2ab plus b squared, yeah? Because that's our formula. And so, again, we're going through the process. What's squared to get 16 is 4. Okay? And so what they're left with is x squared take the 4. So again, they just eradicate all of that out of that solution. Alright? That sounds alright to both of you? Okay. I'll leave you with that? Yep. Alright. Okay, parents, let's have a look at this. So we're looking at G. Yep. 15 a plus 1 all squared take 10 a plus 1. Okay, so the process might be to find the highest common factor of 15 and 10. Yeah. So out the front here, we might have, we'll do it up here, I think, a bit more room. 5 times 3. Would that be right?
Yeah.
A plus 1 all squared. Take 5 times 2, a plus 1. See what we're left with? Yeah? Okay. What's the process we would follow from there? We'd find the common things on either side.
Yeah.
Yeah, and the common thing you have on this side is 5 and one of these, because it's squared.
Yeah.
And a 5 and that. Would that be right?
Yeah.
Okay, so we'd have 5 a plus 1. Would that be right?
Yeah.
Alright. So we've got rid of only one of these, which is something we need to consider. Got rid of that. Got rid of that. Got rid of that. What does that leave us with?
3 bracket a plus 1 negative 2.
Like that, is it? Negative belonging to that. How can we solve that from there? What do they ultimately say the answer is?
5 a plus 1, 3 a plus 1.
5 a plus 1 like that?
Yeah.
Yeah?
Oh,
A
yeah, bracket A plus
plus 1.
1. And then 3 bracket A plus 1. So I'm not sure how they got rid of the 2.
Yeah, A plus 1. 3A plus 1. They seem to have an issue around here, here and here
Oh, okay.
in terms of their solutions, whether they've got an issue all the way through.
Yeah.
Certainly we haven't got rid of the 2, and there's no common factor there to suggest that we should get rid of the 2. So we've definitely got 3A plus 1 left over. But then to have the negative 2 removed for no reason, it wouldn't appear a reason. 5A plus 1. A plus 1 might be a better solution. So there's 3A plus 1, I'd suggest.
Yeah.
Yeah, where we've got 3 take 2 being 1.
Okay.
Does that make sense?
Yeah.
You certainly haven't got this in the test, but
Okay.
I would say at this early stage it'll be a solutions problem.
Yeah.
Can't see that they would get rid of that 2 for any other reason, to be honest with you.
Yeah.
And then we wanted to go through 9, didn't we?
Yeah.
Yeah. So, if I was to say, what is the area of this shape? How would you go about finding the area of that shape?
Of the one you drew.
Yeah.
7 multiplied by 3.
Yep,
Just
which
times
is
width.
good girl. Length times width, 7 times 3, 21 centimetres, importantly squared. And I think that might be something off the last test you didn't acknowledge was the squaring. It's doing area, so it must be squared. So all they're asking you to do is write an expression. An expression's not an equation, so it won't have an equal sign in it. An expression for the area of each of the following regions. So for the blue region. So it's a matter of identifying, isn't it, what my length is and what my width is for this shape. So what might your area be for the blue?
X multiplied by bracket x plus 1 bracket x minus 1.
Good. Alright. This is essentially your width. This is essentially your length, or vice versa. Yeah?
Yeah.
Alright. And then they ask you to fully factorise that. Okay?
Yeah.
Now, what do you acknowledge you've got here? It's probably possibly your perfect squares.
Oh, yeah.
Difference of 2 squares there.
Okay.
Alright, so thinking back to the difference of 2 squares and moving backwards instead of expanding.
Yeah.
Alright. Of the red, the red bang in there, what do we have there?
Bracket x minus 2
Yes.
bracket x plus 1
Now there's a problem there.
yeah, bracket x plus 1 bracket x minus 1.
The problem is that this would have to be plus.
Yeah.
Yeah. If I said that this was, extended to here, and this was 3 centimetres, you would say that that total length from there to there is 7 plus 3.
Yeah.
Yeah. Which would change that to be 10, which would change that to be 30 centimetres squared. Alright, so this side length here for the blue is x plus 1 plus x take 1, which changes around your factorising process.
Yeah.
And this is x take 2, x plus 1 plus x take 1. Okay? So there's some processes that you'd have to go through in order to solve that.
Yeah.
Alright? The only processes, hints that you would get is from whatever's, beyond here. Obviously they're not going to ask you to do stuff out of the blue. It's related to what's up there.
Yeah.
And then in order of, in terms of the total area, again, it becomes x, this distance here, which is the total, becomes x take 2 plus x times x plus 1 plus x, plus in there, x take 1.
Yeah.
Okay, so I'd suggest maybe that's been missing out of your solution, and then from there, obviously, that gives you a bum steer all the way along.
Yeah.
Yeah. Does that make sense?
Yeah.
Work with what you know. You know that this is the case, and then if worst comes to worst, and you'll get worded questions in the test, or diagram questions in the test. Worst comes to worst, put in values for it. Just say, oh, let's just say that's 3 and that's 7. How would I work that out? Oh, it'll be that.
Yeah.
And then follow that process into the equation. Okay?
Yeah.
Is that alright?
Yeah.
To go from there?
Yeah.
Okay.
Thank you.
Okay, so right 391 is the difference of two squares, where you could have, if you were to get something like that, then could you not do something like that? And then you could show that, if I put it underneath, you'd have x plus 17, x take 17. Does that not show the difference of two squares? Yeah. And of course, show that 17 is a factor of 391. You could then use FOIL or difference of two squares to then solve that. And if hopefully it comes out to be something like that, and then you've proved that 17 times 17 is 391. Follow a process like that, maybe. There's probably multiple ways of doing it, Tani. All they're saying is write it as difference of two squares. Well, I guess you just chuck it in to make it look like something that you've had above. Show that 17 is a factor of 391. I guess you're trying to use that process to show that it's 391. Is that alright? But there's probably multiple ways of doing it. That's just off the cuff what I'm thinking. Alright, does that make sense to you?
Yep.
Yep. So all they've done here is they've left out they've squared that, because it's a perfect square, and left this the same. And then what they say is, well, in order to get negative 3 squared, you've got two of those things. So you've got a plus 3, and you've got to take 3, because you've got two of them, yeah? All right, and because it's negative, one has to be plus and one has to be minus. All right, and then if we get rid of that, which we can, because they're the same, we can collect like terms. And so this becomes positive 2 plus 3, which is positive 5. And this becomes positive 2 take 3, number line, which is take 1.
Yeah.
All right, so this one will be x take 3 plus 6, yeah?
Yeah.
And then x plus 3 take 6. Yeah?
Yeah.
And so then you just get rid of those. This becomes what?
Negative 3.
Number line, Jazz. Negative 3, negative 2, negative 1, 0. So we're going negative 3 and we're adding 6. Adding 6, we must go this way.
Positive 3.
Yeah, positive 3. And this one?
positive 3.
We're at positive